Hello, so this is MindMend AI by me. So first, this is me. My name is Sarthak Tayal. I'm a sophomore at Nova High School, and I'm passionate about supporting the well-being of high school and college students, especially as they push through difficult courses and the challenges of them. So on the top left will be the APA citations. There'll be a full citations list at the end of the slides. So our problem statement is many students struggle with mental health issues such as stress, depression, or anxiety, but face time barriers to access support for their well-being. MindMend AI addresses the need for mental health guidance by taking real counselor responses to guide any student to retrieve early emotional support and help in a timely manner. Some subproblems include barriers such as cost, time, or location, not knowing when to find professional help, or discomfort discussing mental health issues to a person. Now, here's our proposed solution. Our AI-enabled solution is a mental health chatbot that provides immediate 24/7 support to students facing anxiety, depression, and emotional stress. It delivers personalized responses based on real counselor data, ensuring relevance and empathy. The chatbot is anonymous and private, which reduces the stigma of seeking help while offering an accessible first step for managing mental health. Now, someone may state that they're more familiar using other AI platforms, such as ChatGPT or Gemini, and so they're more familiar with just asking them questions. However, there's a key difference from MindMend AI to those other AI platforms. Large AI platforms like ChatGPT use social media platforms like Reddit for their counselor data or for their data for emotional responses, which kind of calls in question for the trust of the responses that they give. And so MindMend AI will only take real counselor data, real responses, or real conversations between a user and a counselor. Now, here is some statistics of mental health and issues in students. And so we can see that there's an increase in prevalence of mental health problems. We see a 52% increase in at least one mental health problem in college students since 2013. We see 15% of college students reporting considering suicide, and 40% of college students have considered withdrawing due to emotional stress. Now, with the release again of popular AI models like ChatGPT and Gemini around November 2022 in this graph, we see that there still tends to be an increase in mental health issues in college students and high school students. So, due to this, I want to focus just one platform that is specifically catered and designed to just solve the problem of mental health in these college and high school students. So I've split it up into 4 different categories here. Our first one is going to talk about our data set, which is how do we find and finalize our data set, the incorporation of the data and creating the code, the sample version of the code, and outputting the code. So how do we find and finalize our data set? So we decided that a data set with human to counselor interactions would suit our chatbot the best. After researching, we found research by a user that had data backed by an MIT license on GitHub, which promotes the trust of the source. And so I downloaded it and imported it into Jupyter Notebook and focused on the 2 columns inside of this dataset, which is the user asking a question and the answer with the counselor. So in my code, I imported 3 new things that we haven't talked about before. One is Gradio, which is an open source package that helps build interfaces. TF-IDF Vectorizer helps convert text into numerical features, and cosine similarity from scikit as well. TF-IDF Vectorizer is also from scikit, but the purpose of cosine similarity is actually to work together with TF-IDF Vectorizer in this code to calculate the similarity between 2 vectors that are made with TF-IDF. So here we kind of make a vectorizer and we transform, well, essentially what we're doing is we take text and we're making it into numerical features and numerical values for the computer to compare. So we transform it into numerical values, and then we take the user input, transport that into a numerical value, and then compare it and take the highest similarity of the 2 between the question text of the trusted questions that we have and the answers, and the user input, which is the question that the user has. And then we put those we take the index of that, or we get the index of it, and then we put it back into our original data, and we print out the best math question and the response. And then here is also just a little bit new information here. This is Gradio. We kind of just import a chatbot here, and we're going to input and output text both. And our title is going to be a mental health chatbot and a description of it. So here's actually how it's going to look as we output it for the first time. I've hidden my local IP address here. As you can see, our Gradio interface is going to ask for user input, and where you can type a question, and the user, the backend, will try to find the most similar response that is stored in the dataset. Test cases using R² here will have limited value due to outcome being a retrieved response, as well as cosine similarity already matching the most similar response, the most similar question to a question and a response. And so here are some examples and some test cases of this AI that I've tested. We're going to be talking about just the first example here, where someone has stated, I have trouble going out and meeting new people, and words don't come in my mouth properly when I try to speak. What should I do? And so, as you can see here, it's matching the most relevant question here, and it's very similar to actually what the question is asking. So they're both very similar, and so we can kind of take this, and like any user can type something, and you'll get like a real trusted counter response. Again, the main difference between this and other AI models like ChatGPT and Gemini is that we use real, relevant counsel responses. So the type of AI solution. This specific chatbot is built using NLP, natural language processing, to process user queries and tokens, as well as supervised learning. We use techniques like TF-IDF, term frequency inverse document frequency, to convert text into numerical features. So this chatbot is AI enabled, which means it isn't completely powered by AI, but it uses AI to enhance its ability to find responses. And we use AI for token or query matching in cosine similarity, which compares user input to pre-existing questions. Now, here's sort of the solution workflow or the technique overview of how this actually works. First, someone inputs a query into the Gradio interface. Second, the chatbot processes this function or the function called chatbot inside the code. 3, we use NLP functions within the input. 4, we index and find the closest matching question and then match that to an answer. We cast the index to the column, and then we return the stored counter response from the dataset. Now, this dataset consists of many things, mainly mental health related questions and corresponding counter responses. Those are the two columns that we focused on for this data. We use TF-IDF and cosine similarity to convert text into numerical vectors and compare the similarity of user input text and question text. We directly match queries with answers using similarity measures using cosine similarity. Now, our technology stack. Our backend technology stack is that we use Python with scikit for vectors and comparing similarity. And our front end is that we use Gradio for the user interface to promote easy interaction. So here are the solutions now and what we have for the future. So for now, of course, we tokenize and vectorize input, cast TF and IDF cosine similarity to compare a question to a question and a response. Now, some visions for the future of MindMend AI. We have machine learning models that will learn from the user, sentiment analysis to prioritize urgent queries, and also a feedback loop, which can rate responses to constantly improve, and context awareness to maintain the flow of a conversation. Now, if we were ever to implement machine learning models in the future, because of the limited amount of access that we have to counter data and counter responses, we take as much as we can and only train our data off of counter responses. This way, we ensure that we're not taking any false information or any information that we find off of platforms that aren't very trusted. So here's the conclusion. The AI solution properly uses NLP, natural language processing, to provide relevant mental health support to those who need it in a timely manner. By leveraging TF, IDF, and cosine similarity, the chatbot ensures accurate and personalized responses that are based off of the user question. So incorporating advanced AI techniques like feedback-based learning and sentiment analysis can help the solution's adaptability and effectiveness in the future. And this solution offers a safe, private, and accessible tool that, for now, runs on the local host and is accessible to those who don't have a trustworthy person to speak to. I will also link the whole entire project at the end. I think it's already linked. So you're welcome to fiddle around with it, import it, use it if you'd like to. And yeah, here are some of the citations that I used. I tried to focus on any citations that would have a date of 2022 and after, but there is the exception of one that was released in 2019. Thank you.